Hello and welcome to a Marketing Sherpa webinar. Today we're going to talk about 4 techniques to help you improve your analytics based on customer knowledge. And first of all, we'd like to thank Paramore for sponsoring this webinar. They make it free for you so we can bring smart people like Benjamin Phillip, who I'm about to tell you more about analytics. And Paramore, if you're not familiar with them, they are the digital agency, a full-service interactive agency located in Nashville with happy and successful clients all across America. And we hope we have happy and successful marketers on the line today. I have Benjamin Phillips joining me. He is a data analyst. He knows about these complex analytics and metrics techniques you want to know more about. Just very quickly, his background, he taught at Florida State University before joining us. And thank you for joining us at Mech Labs here, where he works with our research partners. And thank you for joining us today, Ben.
Yeah, thanks for having me, Dan. I'm looking forward to spreading the knowledge about analytics.
One way you can ask your questions is through the ReadyTalk platform, and if you have any problems, any technical problems at all, we also have James from Denver that's going to help you out. But you can also use hashtag #SherpaWebinar on Twitter. That's a way where you can not only ask your questions, but also share your analytics information with others on the line. We usually have a pretty big cross-section of marketers, some experienced, some less experienced. And that's where you can not only ask your questions, but say, hey, this is what works for me, this is what doesn't for analytics. But let's get into exactly what we're going to be talking about today. And as you can see on this chart, this is from our just-released Marketing Analytics Benchmark Report. And this is where what Ben used to help build today's deck. Because as we look at the top challenges, these are a few of the things you're going to be talking about, right, Ben?
Yes, correct. We asked, if they only had blank, their marketing efforts would be substantially more effective. The top response we got was 37% of the respondents actually said an advanced customer behavior analysis would be beneficial to them. In today's webinar, we have a couple examples exactly how you can accomplish that. We also had another one of our top responses was predictive analytics. We have a whole section in today's webinar talking about different types of predictive analytics and sort of the benefits and the holdbacks of those.
And in case you're interested, we will tweet a free excerpt to that Marketing Analytics Benchmark Report through hashtag #SherpaWebinar. But let's get into it. When we talk about marketing analytics, we don't want you to be thinking about this guy, okay? It's not the newsman. It's not the guy telling you what already happened. Sure, your metrics and your analytics data can do that, but that's not where their real power lies, okay? So we're talking about analytics. We want you to think about this guy, the intrepid weatherman, the guy that has to tell you what's going to happen in the future. It's very easy to say a cat got stuck up in a tree, whatever the news is, but to say, hey, there's a 70% chance of rain tomorrow, that guy's really putting himself out on the ledge. So to do that, we've only got a half hour today on this Sherpa webinar, so there's only so much we can do. We can't, dive very deeply into all these different techniques and show you how to do them yourself. So we thought the best thing we can do is bring in a smart analyst like Ben and help you talk more to these people, help you understand the kinds of questions, the kind of things you want to talk to your data analyst about, the kind of statistical techniques you want to use to learn the things you want to learn. And so right here I use Bill Gates as an example because that's, kind of how we all think of a data analyst. And Ben, what's the problem?
Dan, I have a slightly different image in my head of what a data analyst should look like. I see him more like...
Okay. Ben, why is the data analyst Superman? Mild mannered Clark Kent turned into Superman.
Well, the data analyst is Superman because he has the ability to leap conversion rates in a single bound. He can move faster than a speeding ROI. So I think they're a Superman because they have the key to solve any problem you have.
Well, one problem that Ben solved, which I'm very excited, we have 4 techniques now today. The 4th technique is this really, really impressive case study where Ben helped a company find their best and worst customers. And I assume the best customers are the ones you want to get more of, and the worst customers are the ones everyone is happy that you avoid. But let's start out with technique number 1, where we're going to talk about correlation. Tell us more about correlation, Ben.
Right. Correlation is explaining the dependency of 2 variables or 2 data sets on each other. It shows the relationship, and we look at the relationship in 2 ways. We look at it both as the direction of the relationship and also the strength of the relationship. We have positive and negative correlation, or no correlation. Positive is not necessarily a good or a bad thing. Positive just means that they follow the same trend. So if one goes up, the other goes up. Negative correlation means they're going in opposite directions. So if one goes up, the other one's going down. The strength of that relationship can also be measured, and it takes a value between -1 and 1. The closer you're getting to 1 on either spectrum, the stronger the relationship in that trend area. So I've started with a simple kind of example of correlation right here to get the idea in our heads. You see that we have the cross-section of page views and visits has a 0.92 correlation. That is a positive correlation because we have a positive number, and it's a strong positive correlation because we're very close to the number 1 there. You can also look at page rank in page views. It's 0.35. We still have a positive correlation. It's just not as strong. So we can use these numbers to see how one part of your website is actually affecting the other part of the website. Moving beyond the simple diagram, I have a more complex version, and this is something that we would use here at Mech Labs. We look at the correlation between the overall site-wide visits and compare them to the different steps in the funnel on the website. For this diagram, green means positive. The darker the green, the stronger. Red means negative. The darker the red, the stronger the negative correlation. And white represents close to 0, no correlation. For this positive correlation example, I want to show you, if you look at the overall site-wide visits, which is your far left column, and you look at step 3 unique page views and step 4 unique page views, you see we have a very strong positive correlation. What that's telling us is that if we push traffic to the main website, that we're still getting a motivated traffic source because they're making it all the way through to the bottom of the funnel. So the more traffic we can push to this particular site, the more traffic we're going to get in the end and hopefully get more conversions based on that.
And I can see instantly how this can help. I mean, I think we all have this very base understanding of correlation, but just so you know, Ben created all of these techniques based on real work he does with research partners and questions he gets from brand-side marketers like you every day. And I think one of the reasons we want to talk about correlation, it really shows where we should put in our efforts, right? If we make a change here, how does it affect other things? Or if we make a change here, it's great because we don't affect other things, right?
Yes, exactly. That's what we're looking at. We kind of want to see if we make a change on one particular part, how is that going to affect the rest of our marketing strategy? Is it going to affect another area we're changing as well? There's just a whole plethora of things you can figure out with these correlations that kind of give you that insight to the future to know, hey, I'm okay to test here because it's not going to affect, 3 steps down the funnel, or it might affect 3 steps down the funnel.
Okay, I think we have 2 other quick examples.
Right. So this is one with the white cells. We have no correlation, which means I can affect one area without affecting another area. So for instance, if you look at step 2 page views and you look at step 3 page views, we're almost at completely white cell there. What that means is that anything I do on step 2 should not have a major effect on the next step 3. So I can test or I can change stuff in that area and not worry about a major effect happening later on. Finally, a negative correlation in red, it indicates that 2 things are moving in the opposite direction of each other. So you see site-wide visits for this one, the far left column, and we look at the average visit duration, also in the third from the top. We have a negative correlation. So as the site-wide visits are increasing, the average visit duration is actually going down. What's that telling me? That's telling me I'm sending motivated traffic through my site because I'm sending good quality traffic, they're staying on my site, and they're seeing what I want them to see.
All right, thanks, Ben. We have this great comment here. I'm looking at #Sherpa webinar and tweet that. Kate says, it's been 15 years since I took a statistics class. Will this Sherpa webinar on improving analytics break my brain? Probably. Well, we hope not, Kate, but we do hope to be able to arm you with the types of things you can talk to your data analyst about to answer questions like this. Here's a question we got from Jimmy before this webinar. Jimmy says, for agencies that report valuable metrics such as these on a regular basis, monthly, to our clients, can you touch on methods for creating templated ongoing reports? And Ben, I believe you would recommend profit analysis, right?
Right. Profit analysis is a very key aspect to the testing and optimization. We templatize these things. So, when we're talking about something like profit, we don't want to just look at the end of the year. We want to look every month, every week sometimes. So you can create a template in Excel or whatever other metric systems you're using, and all you have to do once you have the template created is you can just input the new information, the new data, and refresh it, and then it will automatically update every part of it. I highly recommend that if you're going to get anywhere near even a medium level of analytics use, that you start making these templates right now. It'll save you a lot of time as you go through the rest of your testing and your rest of your marketing strategies.
So Ben's got some profit analysis to show you, and I don't expect you to be able to look at the profit analysis and understand each and everything on here, but we are going to put this up on the MarketingSherpa slide share right after this presentation. So while Ben's walking you through at a high level, some of the more complex wording and some of the more complex numbers, just get a sense of what Ben's talking about now, and then later you can use that as you sit down with your data analyst by going to slide share, the MarketingSherpa slide share.
All right. So this is an example of a profit analysis that I did. Some of the key aspects of profit analysis is it helps us know what's going to impact our change, or which changes are going to impact our bottom line the most. It also lets us know kind of a baseline of how much we can expect on the back end, the revenue, the profit numbers, how much we can expect to gain by making these changes. And we can look at the changes for individual tests, individual channels. We can also look not only what we're doing now, we can use this as a kind of a post-testing strategy thing, where we have the lifts that we actually saw put in here, plus the future potential. By inputting both those, we're able to see the past, present, and the future all at once. So the way this works is we have the current step arrivals, the current conversion rates, our lift factors, and that leaves us with the surviving prospects. And then you can get up with your financial teams, your accounting teams to figure out the average value of a customer and use that to calculate the increase in the bottom line. So this one's set at 0, as if we did nothing and no changes. The next one I'm going to show you actually has what we would call the present. So we've made some changes on our website. We've looked at the new conversion rate, and we've calculated what that relative lift was. We put that relative lift in the fourth to the right column, the CR optimization factor, and that shows us what all these additive lifts through the 4 tests for every channel that we've tested on affects the bottom line. And Dan, you can see that these, what I would consider incremental, not too large kind of lifts, actually generated 13.8% relative change in the profit.
Ben, 13.8% is not enough for me. Show me the money. What else can we do?
Well, once we've looked at this and we know how our strategies have affected now, we can have a better idea of how we can expect them to do if we keep working in these same areas. So I can put in the future testing lift potential where I think I can get these. So now I have my past, which is my ones I used to build the model, the current. I have the present, where we already put our relative lifts in for this season. The next time, where we think we're going to be, well, if we keep testing, we put the conversion relative lifts in that we think we can get. And now you can see by the time a second round of testing and optimization is done, we've now gone up to 30.9% relative lift in the bottom line. And that's pretty substantial.
So this third technique, I got to admit, I'm a analytics neophyte, and I've learned a lot from Ben about this, because we talked about regression modeling. I just thought about, hey, a simple linear regression like you learn about in Marketing 101, but Ben said from dealing with marketers, regression is something that's probably very misunderstood, right? Can you tell us about different types of regression modeling types?
Right. I get questions all the time. Can't you just make a regression out of this, or can't you put this in a regression? What most people don't realize, unless they're in the analytics world, is that regression is a overarching term people use. There's tons of different types of regression. They all have their benefits. They all have their downsides. It's really dependent on your data, how your data is as far as how it looks on a graph, how it interacts with each other, the form it takes, the type of data you have, whether it be numeric data or some sort of categorical variable. So when you come to your data analyst and you say, can I get a regression, hopefully after you watch this section, technique number 3, you'll have a little better idea of what you really want to ask for. So there are some limits to regression. Nothing's perfect. The one thing that I really want to I get this question all the time is, well, so does this work 5 years from now? The truth is, your regression model is actually only as good as the data you put into it. So if I have a year's worth of data, and I want to say, well, I have person A who has these 3 attributes, then you can predict where that person would fall from a conversion rate standpoint or any other metric you want to look at. But it doesn't really extend past that range of the data. So you can't use a regression model based on last year to necessarily look 20 years down the future. You can create it and you can look 20 years down, and if you make the naive assumption that everything's going to stay the same from here to the end of the 20 years, then you can get a relative idea, but it's definitely not an absolute that you're definitely going to get there, because things change. There's historic events that change, and those can cause the model to be completely void sometimes. Another thing is outliers. So if people have extreme values anywhere, those can have a huge influence on any kind of predictive model, any kind of regression type. There's lurking variables. Now, a lurking variable is a variable that is having an effect on the dependent variable, which is the one we're trying to predict. It's having an effect, however, our model didn't actually consider it. For whatever reason, we weren't tracking it, we don't have data for it, or we just forgot and accidentally left it out. So we have a value, it's called the R-squared value, and the R-squared value tells us how much of the variation we've accounted for in our model. And rarely do we ever get to 100% of the variation. So there are these lurking variables, and it's just something you want to be aware of. And when you go to your analytics person, you want to make sure that you give them too much information. It's a lot easier for an analytics person to go from too much to use what they need and cut what they don't need out than it is for them to keep coming back and ask you questions.
Yeah, and I want to reiterate that point just for a moment about lurking variables and just giving your analysts too much, because, correct me if I'm wrong, Ben, why this is so important partly too is when they're setting up their analytics or metrics platform so they're tracking the right things, right? Because if you're not given the right inputs and the ability to track those, either it's way more time for that on the analyst's part to generate something, or they might not even be able to generate something meaningful to begin with.
Right. There are statistical methods to figure out missing variables and try to estimate what they would have been, but all of those come with margin of error. So the more you're trying to do that, the less accurate your model tends to be in general. So you definitely want to give them everything you can, give them more than enough. And also give them the granularity. It's a lot easier for us to take something and aggregate it if we have it all pieced out bit by bit than it is for us to take an aggregate number and try to make something useful out of it if it's not there. So the different types of regression modeling techniques. First of all, you have your typical linear regression. It's when we have one variable, we're trying to explain another variable with it. This is the top right diagram you see. You notice the data points fall in a straight line. That's when you can use a linear regression. There's also a multiple variable regression, which uses more than just one variable to explain, but it follows a lot of the same rules, a lot of the same assumptions. The ordinary least squares is a way, I just mentioned a second ago, if you have something that you don't know the parameter of it, you can use ordinary least squares to try to estimate that parameter. It's very often used in economics, so if you're trying to do metrics to look at revenue generation, then you might want to use an ordinary least squares model. Polynomial regression is a great regression. A lot of times we don't see that linear trend in the top right. We see something that looks more like the bottom right diagram. So you have this curve. It doesn't have to be one curve. It can be many curves or very complex curves. But polynomial regression tries to fit these abnormal lines. And a lot of times you want to use a polynomial regression if it's needed, because your data and your analytics are going to be a lot better because of it. The generalized linear model, it uses a lot of the same techniques as linear regression, but it comes from random variables that don't follow the normal pattern. And when I mean normal, I mean the standard normal bell curve. It's really useful, but it takes some time and it has some limitations. But and underneath it comes the Poisson regression. Now, Poisson regression is an example that you use to count data, so it can tell you like rates. If you want to know how many visitors should I expect in July, you can use a Poisson regression to estimate how many visitors you can expect, how many conversions you can expect. And this comes in really handy because sometimes we have a limitation. Maybe I can't sell 400 widgets. My max is 350 widgets. I can only sell that many in a month. If I use a Poisson regression to look at my growth rates, then I know ahead of time that I'm going to be over that 350 limit in July, so I can start putting in resources to be able to meet the demand, or I can change and limit how many that I'm able to sell. Logistic regression is very useful. It's a way to use categorical data. It means the dependent variable, the variable we're trying to leak, does not take on a number. So what it really does is it attributes probabilities to the different levels, and then based on the attributes you put in, you can see what the probability that you fall into a certain category, as opposed to taking on a numerical value. Nonlinear regression is exactly what it sounds like. It's data that doesn't follow a linear path at all. Non-parametric is when you have a parameter issue, there's no parameters set for the model. And then finally, I'd like to talk to you about an analysis of variance. Most of us have probably heard of it called ANOVA. What this does is it looks at the variance of a variable and looks at the variance of another variable, and it tries to look at where that variance is coming and which one has a higher variance than the other. It's very effective for comparing multiple groups. So if you had, 3 treatments and two things you were changing on in each treatment, you could look at the different groups that viewed everything and kind of compare those groups to each other.
And correct me if I'm wrong, but ANOVA also helps for those on the line doing A/B testing to help get a statistical confidence level for A/B tests, right?
Yeah, it can be used for that. It's typically we think of t-tests and things like that for that, but definitely, especially if you have a categorical type thing, like is your call to action red, green, orange, something you can't necessarily put a number to.
Okay. In just one moment, Ben is going to present a very interesting case study in technique number 4 about how he helped a customer find the best and worst, how he helped a research partner find the best and worst customers for them, something I think we're all interested in, finding more of our better customers and less of our worst customers. However, let me first thank Paramore. They are the sponsor of this webinar, and they are the reason we are able to provide it for free. If you're not familiar with Paramore, stop reporting, start improving. That's Paramore's philosophy on analytics. Simply measuring page views and path analysis doesn't lead to action. Paramore combines clickstream and voice of customer analysis to measure things like task completion rates and segmented visitor trends, giving us actionable insights that we can then use to improve a website or campaign's performance. The more usable your website is, the better it is for both your users and for search engines. The more personal, targeted, and engaging your media is, the more customers you'll get. By continuing to modify and optimize a site design or landing page throughout its life cycle, you'll not only have high-performing campaigns, you'll have happier clients, something we all want. So you can learn more on how Paramore uses analytics to make digital campaigns better at paramore.com/analytics. You can see the URL right there. And also we wanted to mention we have our new 2013 Marketing Analytics Benchmark Report. It is filled with hundreds of slides with data on how your peers are using analytics. Marketers have told us this can really help them when they're setting budgets, trying to convince their business leaders to set budgets, or if they're an agency, trying to show their clients what others are doing. For that reason, it is now in a handy PowerPoint format. So you can simply take those slides and put them into your own presentations. You can see all webinar attendees are going to get a $100 discount code for sitting here for half an hour and listening to us talk about analytics. But let's get right into it. At technique number 4, decision trees, because we had a question here from Dave. Dave wants to know, how can you use analytics to develop a more effective media strategy? And one way to do that is with decision trees, right, Ben?
Right. Decision trees take the data you have and they predict the outcome. So if I have an attribute associated to myself, what is the chance that I fall into outcome 1, 2, or 3? So you can use the data you have and the data you gain from the web and use these decision trees to actually predict the outcome. And what that gives you is a set of attributes that increase conversion or make it a best customer, for instance, as the case study will show. So you can actually use those and take those attributes and apply them to media by directly marketing to an age group or a location or some other variable like that. So it makes it more transferable. The decision trees, that we call them trees because the diagram on the right clearly looks kind of like a tree. We have a starting point and all these branches that come off, and in the end we have an outcome, and that gives us a probability of conversion or whatever metric you're trying to predict. So it's very useful. The case study we're going to look at, we were asked to try to identify the best and worst customers for one of our partners. They surveyed their employees and had them write down the 10 best and 10 worst customers they normally deal with. We took their standard database of attributes, so this would be like your pharmographic information, location, industry, number of transactions, revenue, number of employees, things that they would count, that they would collect with every customer they started business with, and we tried to use that to try to help them focus their strategy. Their problem was they had way too many customers and not enough sales guys, so they wanted to actually focus their sales and marketing teams to specific areas to try to collect the best customers they could. It's probably we'd all wish we had, I'm sure. So here's what our decision tree looks like. This is just kind of a high-level overview of it. So you can see the tree. We have the starting node and then the terminal nodes at the end. Jumping right in, the right side, the first split we looked at was the revenue figure. So this branch has companies that had less than $981,456 in revenue. Just that factor alone got us to 91% probability of being a best customer. The next split it down by the number of employees. Now the probability goes from 91 to 99% that they're going to be a best customer if they have less than the stated revenue and they also have less than 1,000 employees. It's not very intuitive to us. Why would I want to do business with companies that make less money and don't have enough employees? I want to do business with the big boys. Well, this model actually showed that these people, and we went back and asked them, and what it really was is that they had less red tape they had to go through, less revisions process. They had less people they had to show it to. And these people were a lot easier to work with, and they could turn them over and generate the money quicker. The other side now, so we've looked at the less than 981,000. Now we're looking at greater than. Just being greater than that figure had a 75% probability of being worst. Once we look at the second split, we now have a spend less than $10,564. Now this is the amount of money they spent with the customer year to date. The probability jumps up all the way to 98% of being a worse customer with those two factors. The third split, once again, was the employee size. Having less than 200 employees actually changed. So we had the first two were worse, but now we've taken the same attributes that said we were going to be a worse customer, but by putting in the fact that they had less than 200 employees, they go from being worse to actually being a best customer. And if they had more than the 12 transaction, it goes up to 94%. So these aren't necessarily all-inclusive, and the different attributes can mean different things. So if you stop at one point, you have a worst. If you keep going, you can make that worst into a best based on further the different attributes. We looked at it again, and we wanted to look at location because they're really, and type. The right split looked very similar to the first one, but the left split now shows that customers who had large revenue and that were located in Asia, Australia, or North and South America had a 91% chance of being a worse customer. In certain industries, that probability skyrocketed to almost 99% chance of being a worse customer. So what this is doing is, and I'll ask you, Dan, if you were in charge of the marketing spend, where would you put your marketing money at right now? Would you put it in Asia?
Well, I'm going all in Europe and Africa.
Right. We made the split, and it turned out that the companies that were in Europe and Africa actually had a 96% chance of being a best customer. So what we've done is we've looked and we've focused. We now know the type of people, we know where the people are, and we can start to use a more focused budget. Now, the one thing I do want to mean, it does not mean that the other companies shouldn't be considered. Sometimes we need that worst, quote-unquote, customer because they bring in so much revenue. They're the ones that keep the lights on. But when you can minimize the worst and increase the best, I think that's a pretty good day.
Excellent, Ben. Thank you very much. As we talked about today, correlation, profit analysis, regression modeling types, and decision trees. And we have time for just one last question. This one comes from #SherpaWebinar Christine. She says, I find decision trees not to be very helpful as they end up with a ton of branches that are much too granular to apply. Tips?
Yes, Christine. There's actually a formula that we use to figure out what your optimal number of branches are, because you're exactly right. You can break this thing down, and I've seen people do them. They have 56 different splits, which is just it's almost a mess to even start to look at it. But you can limit the number of splits you use to increase the usability of the actual thing. And you can use, I'm going to throw out a word, it's called K-folded cross-validation. That will help you ensure that your model is actually is actually performing well. You can calculate R squared, and you can actually give an actual equation for these. So yes, you're right, Christine. You don't want to get too many splits and get it too confusing, but there is some good methods for getting around that.
Excellent. Well, we are at 1:30, so I want to thank you, Ben. I want to thank you, Christine, for your question. I want to thank everyone on the line for calling in today. And thanks for joining us for our Marketing Sherpa webinar.